Hello and welcome to a new course on Generative Adversarial Networks, GANs with PyTorch. This is your host, Mustafa Qamar-ud-Din. My name is Mustafa and I'm a top-rated machine learning engineer, and I have been in the software development industry for over 10 years. I've been working with many startups on solving challenges in e-commerce, computer vision, recommender systems, and financial trading. In the year 2015, Ian Goodfellow, a PhD researcher and a machine learning engineer at Google, introduced the concept of generative adversarial networks, in which there is a min-max game, a competition between the generator model and the discriminator model. The generator is trying to generate images that are very close to real images, and the discriminator is trying to find out whether they are real or fake. The idea may seem intuitive, but it had a very dramatic effects in the area of deep learning and machine learning, and it has introduced and opened the door wide to a lot of applications that go beyond imagination. For example, we can see here a video sequence generated by a generative adversarial network, in which it learns the dance, the pose, the motion from an input sequence and uses it to generate a completely new random sequence for a different person that may not even exist in real life. This is only one application of generative adversarial networks. A lot of applications exist in entertainment, in games, in graphics, augmented and virtual reality, and even for generating synthetic datasets for medical imaging and healthcare. Very recently, PyTorch, a deep learning library introduced by Facebook, has been the state of the art and the favorite tool for most machine learning and deep learning researchers and implementers who want to quickly prototype their ideas without worrying too much about syntax issues. PyTorch gives you the flexibility to customize every single aspect of the neural network training, starting with the forward and the backward path, the gradient propagation, and how the loss function is calculated and optimized. These are all required features for implementing generative adversarial networks, GANs, and if you come through, you will find it the most widely adopted deep learning library tool for implementing GANs in almost all of the research papers available on GitHub and on the archives. In this course, we will learn the most commonly used modules and ideas for GANs, and we will have the right balance between theory and implementation. We will take you from zero to hero by introducing the simple ideas first and then incrementally adding up to those ideas and following a streamline of ideas towards the most advanced and complex implementations of GANs. In section 1, Introduction to PyTorch for GANs, we will learn the basics of PyTorch. So whether you have used it before or you are coming from a background in TensorFlow or Keras, we will introduce you to the forward and backward propagation mechanisms, the autograd mechanism, and how to implement custom loss functions. In section 2, Generate handwritten digits with vanilla GANs, we will implement the very first GAN ideas introduced in the paper published by Ian Goodfellow in 2015, and we'll use it to generate images similar to the ones found in the MNIST dataset, that is, handwritten digits. In section 3, Generate specific digits with conditional GANs, we will learn how to control the output of the generator by adding a condition so that we can get images from a specific class with a specific label. For example, when working with MNIST dataset, we don't want to get a random digit or a random number, but we only want to get number 1 or number 2, for example. We also learn the Wasserstein or the Wasserstein loss function. In this paper, a lot of ideas were introduced that help improve the performance and increase the quality of the images generated by the GANs. In section 4, diving deeper with a deep convolutional GAN, we will learn about convolutional networks, tri-dot convolutions, transpose convolutions, and how to use convolutions for both generators and discriminators. Moreover, we introduce the idea of multiple loss functions and how to use them to fine-tune the results and increase the accuracy and the quality of the generated images. I have come across research papers that use up to 4 loss functions in order to get a very fine-grained, fine-tuned results from GANs. This is a very essential skill that we will learn together along the way. The GAN model that we will implement in this section will be trained on the UC birds dataset, and we'll use it to generate images of birds and use multiple loss functions to control the accuracy of the generator. The first loss function will tell whether the image is real or fake. The other loss function will tell whether the image belongs to the right class that was given as a condition to the discriminator or not. And we'll see how this improves the accuracy and the quality of the generated images by the generator model. In section 5, generate realistic human faces with progressive GANs, we introduce one of the revolutionary ideas in the area of GANs, that is progressive GANs. This idea was applied on celebrity dataset in order to generate very realistic, celebrity-like human faces. Even a human being will not be able to tell whether these images are real or fake. We will introduce the concepts behind progressive GANs and implement a progressive GAN and train it on the celebrities dataset. We will also learn a lot of hints, tips, and tricks for optimizing the performance and fine-tuning the training of GANs. In section 6, generate videos from other videos, we will introduce the Vid2vid GAN, introduced by NVIDIA very recently, and from which we obtained this animation in the previous slide. We will learn how to implement it, how it works, and how to fine-tune it. We'll train it on the YouTube Dance Video Dataset, and we will follow the ideas from the very beginning, starting with the UNet architecture, passing by the Pix-to-Pix GAN, and finally learning the Vid2vid GAN. By the end of this course, you will have learned a lot of concepts and got your hands on a lot of projects that will help you in your career path and also in your future research. I shall be waiting for you in the first section. Let's get started.